वन ऑफ इट्स साइड कैलकुलेट करना है BC। द सेम मेथड किया क्या, इसके पैरेलल एक स्ट्रिप कट कर ली PQ जो आपको डायग्राम में है। ओके, फर्स्ट ऑफ ऑल क्या करेंगे, PQ का मास कैलकुलेट करेंगे। तो यहां पर आपके पास दो ट्रायंगल आ गए, वन इज APQ, वन इज ABC, both are equivalent. So PQ by A is the side BC, will be equal to X by P. From here PQ is AX by P. Assume its breadth is delta X, mass of the lamina is capital M. So mass per unit area will be M by area of the triangle, that is half AP. P is the perpendicular length. Okay, so it's 2M by AP. This is the mass per unit area. And now mass of PQ, it will be area of PQ, that is 2M by APX into PQ. This will be the mass of the strip. Now moment of inertia of this strip about BC. So the distance, perpendicular distance of PQ from BC, it will be P minus X, because the total length is P. We are assuming X is from A. The distance of PQ from A is X. So the distance of PQ from BC is P minus X. Okay, and now its moment of inertia will be mass into P minus X square. Okay, total moment of inertia will be integration from 0 to P. Clear? So this is the total moment of inertia. After that, we are having the example of the elliptic disc. We are considering an ellipse, and this time we have to find out the moment of inertia of this disc. Okay, again we have to find out the moment of inertia about OX, or we can say A prime A. So we have cutted the strip into lines like PQRS. Now we are having a rod. To find out the moment of inertia of this rod about A prime. A prime is perpendicular to this rod and passing through its center. So second article will be used. First of all, moment of inertia of the strip is to be obtained. If XY are the coordinates of PQ, then the length of PR is 2Y. Delta X its breadth, rho mass per unit area, and then according to that article, its moment of inertia will be mass into Y square by 3. Moment of inertia of the whole lamina will be integration from minus A to A. It is obtained and the integration is solved. So after solving the integration, we will have pi AB cube rho by 4, where rho is the mass per unit area. After that, assume M is the total mass of the lamina. So rho is obtained. It will be M by pi AB. And from here, we will have moment of inertia of the elliptic lamina about OX is MB square by 4. Again, moment of inertia of elliptic lamina about OY, it will be MS square by 4. Okay. Again, using the theorem of perpendicular axis, what we will have, if we are to find out the moment of inertia of the elliptic lamina about a line passing through the center and perpendicular to the plane of the lamina, then it will be the sum of both the moment of inertia. So it will be 1 by 4 MS square plus B square. Is it okay? After that, we have to find out the moment of inertia of a circle about one of its diameter. However, the proof is given, but instead of discussing all this proof, in the case of elliptic lamina, the sides were 2A, 2B, but in case of a circle, both the sides will be equal. So if A is the radius, so major axis and minor axis both will be 2A. So moment of inertia of the circle about any of its diameter will be m by 4 a square, and about a line passing through its center and perpendicular to its plane, then in this last line it will be m by 4 a square plus a square. So it will be m a square by 2. Is it okay? However, a parallel proof is given. It is similar to that of the elliptic lamina. You can read it or you can use that. Again, about its center and perpendicular to its plane, we have discussed it. Circular disc is given. This time, a circular disc is given. Again, you can see in the diagram. Disc means it's not only a hoop. The whole area is covered. So, we are taking a particle somewhere in the disc such that its distance from the center is small r, and assuming its breadth is delta r. Okay, if that particle creates an angle delta theta, then the area of the strip will be r delta theta into delta r, because if we are talking about this portion that I have selected, the radius is r, delta theta is the angle it creates. So length of the arc will be radius into angle. So it will be r delta theta. We are assuming delta r its breadth. So the total area will be r delta theta delta r. And now if m is the total mass, then we will find out the limits, theta from 0 to 2 pi and r from 0 to a, whatever. And after that, we can find out the moment of inertia of this part about any axis, whatever is asked. Okay, so it is solved. If we are to find out the moment of inertia about OX, about x-axis, then since it creates an angle theta with the x-axis, okay, its distance of this particle about x-axis will be r sine theta, because we will draw a perpendicular from that part to x-axis, and now we are having a triangle started from the center of the circle, moving up the hypotenuse is from center to the particle, perpendicular is from particle to x-axis, and base is the x-axis. Angle is theta, so the perpendicular will be r sine theta. And now moment of inertia of this particle about OX will be mass of this into r sine theta square. Of the whole disk, we can find out the integration 0 to a and 0 to 2 pi. Solving this, we will have the moment of inertia of the circle. Oh, sorry, disk. After that, we are having a sphere. To find out the moment of inertia of the sphere, we have cutted the sphere into slices, and now we are having circular disk. And then, using that result, the moment of inertia of all the disk is obtained, and then integration is applied. Again, next article is of hollow sphere. Again, some ring shaped regions are cutted. Like we have taken a small portion on the boundary, and then we have cutted the ring on the boundary. Then the moment of inertia of this ring about AB is obtained using the article of the circle. Okay, and after that integration is applied. Then write circular cylinder. In this, we are having a right circular cylinder. We have to find out the moment of inertia about its axis. Okay, students. So to obtain the moment of inertia of the right circular cylinder about its axis, we had cutted the right circular cylinder like the disc, circular disc. So just cut the right circular cylinder. Again, I would like to give the example of the uh, pack of breads, but this time assume all the breads are circular. So we are having a right circular cylinder. Every slice is a disc, and now we have to find out the moment of inertia about its axis. So we have to find out the moment of inertia of the disc about a line passing through its center. So it's easy one. Just using the article of the disc, we can obtain the moment of inertia, and then we can integrate from 0 to h the limits for the rectangular lamina. Is it okay? After that, again, this time we have to find out the moment of inertia of the truncated cone. Truncated cone means it's a cone, or it's like a bucket type that is cutted from the bottom side. So it will be solved using again the article of we can say of disc, and to complete it we will make a whole cone, not the truncated one. Okay, now assume from the vertex the height of the cone is something h. Assume the radius of the base is b and that of the upper side is a. Angle that it creates with the the vertex is alpha. So using the triangle, we are having a triangle O1, and then the last one. We will have that this height is b cot alpha and the whole height is a cot alpha. Now assume there is some disk at a height x, so the radius of that disk will be x tan alpha. And now using the example of the disk, we can obtain this the moment of inertia of this disk, and after that we will integrate it from b cot alpha to a cot alpha, because we have to find out the moment of inertia of this portion only. This portion starts from b cot alpha and ends at a cot alpha. So the limits of integration are b cot alpha to a cot alpha. And if we have to find out the moment of inertia of the whole cone, then we will find out the moment of inertia from 0 to a cot alpha. And if h height is given, then the limits of the integration will be 0 to h. Because in the we will discuss this article later on, so we will skip it there. It's here. A solid cone is given. So here the limits are 0 to h. Now we are having the theorem of parallel axis. Okay, this theorem states that the moment of inertia about the axis through the center of gravity are given. A body is given, its center of gravity is considered, about the axis through center of gravity are given. and we have to find out the moment and product of inertia about some axis parallel to those axes. So I think a diagram is there to help you people to understand. Yes, it's here. A body is given, its center of gravity is given. This one. Say it is G. X prime, Y prime, Z prime are the axes passing through this. And the moment of inertia about these axes are given. Now we have to find out the moment of inertia about some other axes, say OX, OY, OZ. These are not necessarily will be inside the body, might be the O center is outside the body. Okay, so we are just assuming that the coordinates of center of gravity are x bar, y bar, z bar about the new axis. Consider any point P and assume its coordinates with respect to the new axis are x, y, z, and with respect to center of gravity are x prime, y prime, z prime. Then all of we know that x will be equal to x bar plus x prime, y will be equal to y bar plus y prime, and z will be equal to z bar plus z prime. Now the moment of inertia of the body about OX, it will be summation m y square plus z square according to the definition. Replacing the values of y and z, we will have summation m y bar plus y prime square plus z bar plus z prime square. Opening these squares, we will have all these terms. Summation m y bar plus z bar square, summation m y prime square plus z prime square plus these two terms. Now, all of we know that G is the center of gravity. So according to the centroid property, summation m x prime will be 0, summation m y prime will be 0, and summation m z prime will be 0. So the last two terms of the previous expression are 0. These two terms are 0. So what we are having? Only the first two terms. Okay. Now the moment of inertia about OX is summation m y bar square plus z bar square plus summation m y prime square plus z prime square. But y bar and z bar, these are the fixed coordinates because center of gravity is fixed. So if these are the fixed quantities, so y bar square plus z bar square, it's a constant quantity. Considering it is as the common part, we will have summation m plus other second quantity is moment of inertia of the body about gx prime. Summation m, it's the mass of the body. So it is m y bar square plus z bar square plus moment of inertia of the body about gx prime. Okay, capital M into y bar square plus z bar square. Y bar, z bar, these are the coordinates of center of gravity. So the first quantity is the moment of inertia of the mass m assumed to be placed at the center of gravity about OX. Means we are considering that the whole mass is at center of gravity and then taking the moment of inertia about OX, it will be m y bar square plus z bar square. So it is moment of inertia of the mass m placed at G about OX and moment of inertia of the body about Gx prime. Okay, so let me tell you what we did. We were to find out the moment of inertia of the body about OX, about this axis. What we did, we assumed that the whole mass is at the center of gravity. The whole mass is at this place, and we obtained the moment of inertia of this point about OX. Means whole mass at G and then perpendicular distance of G from OX plus the moment of inertia of the body about Gx prime, about this axis, which is given. Okay, so this is the moment of inertia of the body about OX. Similarly, the product of inertia will be obtained, and in the similar pattern it will be product of inertia of the body assumed to be the whole mass at center of gravity, and then product of inertia about gx prime, gy prime, and then product of inertia about OX when the whole mass is at G. After that, we are having theorem of perpendicular axis. Basically, what happens? Moment of inertia about OX are given, about OY are given, and then we are to find out the moment of inertia about OZ in the plane. Moment of inertia in the plane are given. When we are talking about the plane, then the Z is coordinate is 0. So A will be summation m y square, B will be summation m x square, and C will be summation m x square plus y square. It is A plus B. Okay. So this is theorem of perpendicular axis. After that, some examples are discussed. I'm skipping this one because the next one will be easy to understand. In this, the triangle properties of the triangle are given. Students, let me tell you one thing. Up to now, whatever we have discussed, all the bodies are discussed. Their moment of inertia about some lines are found. But the one common thing was there, that all the lines about which we obtained the moment of inertia were passing through some point of the body. Theorem of parallel axis will be used to obtain the moment of inertia about a line which does not passes through the body. Okay, so some examples are given. I'm letting all these examples that you will read all these. I think 3 examples are there. Yes. Okay, in the next lecture we will discuss further. You can read all these. Found any problem, we will discuss in the next class.